How's it going, everybody? My name is Avery, and today is Saturday, and that means it's day 2 of ray tracing in one weekend. If you guys haven't watched the last episode that came out yesterday, we started the ray tracing series where we're following along the book written by Peter Shirley, and we're using most of the stuff that he has, and we're also setting up some stuff in STL too. So go ahead and watch that video first. In the last video, so I can quickly show you what we ended off with, we created this red circle, as you can see here, and there's the background, and all of this, it looks pretty simple, but it's all being ray traced. So we're going to be moving on from here. In this video, we're going to actually have a lot more things that look a lot nicer in this. We're going to be covering some shading stuff, we're going to cover different material types, and some anti-aliasing, and some diffusion, and we're going to be talking all about it. So stick along, and by the end of this video, end of today, we're going to have this. And by the end of tomorrow, the end of the weekend, we're going to be having this. So, hope you guys enjoy this video and stay tuned. So yeah, as I mentioned, this is what we ended up with last episode. So we're going to go from here. This is a plain red circle. So let's go ahead and add some shading and make it look a little bit nicer. So let's close this, and in our code, this is the main file that we have, and we're going to jump around a little bit. Over here, show you example. So here's our circle, and we're going to want to have basically just some shading around it. And the shading is going to be some colors from different angles. It's going to have different colors on it. But we basically are going to have the center. We're going to pick a random point. So it can be any random point. And then we're going to find that offset from the point and the edge. And we're going to be able to set a color for it, basically. We can do that here in the main class. So we're going to want to change some of the hit sphere and some of the color function. These are right here for now, but we're going to be moving these in a little bit. But we can leave them here for now. So here we have our discriminant. Now that we know it, we're going to be able to use that to figure out some more about, to figure out what color and the shading is going to be. So it's going to be discriminant is less than 0. Then we're going to want to return -1. And if it's not, then we're going to return, we can get rid of this. Let's return -b minus the square root of the discriminant. Close that off and divide that by 2.0 times a. And now this is going to be returning a float, now that it's not returning a Boolean anymore. And now that it's returning a float, we're going to have to change something down here as well. So we have this if statement. So what we can do is float t equals hit sphere, and should be able to copy this right here. Okay, now that we got that, we'll do if t is greater than 0. And if it is, we're going to do vec3 in equals unit vector r point at parameter. We're going to point it towards t and then offset it by 0, 0, -1. Let's close that off. And then right here we can return it. So it's going to return 0.5 times vec3 in x plus 1 in y plus 1 and in z plus 1. We can get rid of this one right here, and I believe this isn't going to be changed. Okay, because this is just going to be for the sky basically, but this is for the material. If it's less than 0, that means there's nothing, so it's going to be the sky. So we can go ahead and build this, and we can run it as well. Okay, so this is going to need to have, what line is that on? 24. Okay, 24 is going to be vec3 and float, redecoration of float t. So line 28. Okay. I'm sure you guys might notice some of these things before I even get them fixed. But that should do it. We can run it, and let's see it display. take a second, and here we go. Our red circle now has some shading. So you can see there's blue over here and green up here and purple on this side. So it has the shading based on the center, and then it checks all the points around the edges. Or not around the edges, but it picks some random points. So now leave it on that. We're going to set up a sphere underneath it that's a lot larger, so it kind of looks like a landscape. And it's already green at top, so it's going to look pretty nice. And to do that, we're going to be creating some classes that keep track of all the spheres, because right now we're just doing one sphere, but we're going to have multiple. So we're going to be doing that. We're going to be creating a new file. This is going to be called our hittable class. So we can just go ahead and save that. It's in the right directory. So hittable.h, save it as such. And now we can do a struct hit record, and we'll do float t, vec3 p, and vec3 normal. So this is basically just keeping track if it's been hit or not. And then we'll have a hittable class as well. We'll make that public. We'll close that off. Then here we're going to set up a virtual Boolean function. We're later going to have different types of materials and stuff and things like that, so we're going to be using some of this stuff in it as well. So const array, so it's going to take in the array, it's going to take in a minimum and a maximum, and a hit record. Const equals 0. So I guess we'll explain this a little bit more once we start using it. And now we're going to create a sphere class as well. This is include hittable. Then we'll have class sphere, public hittable, and public as well, and sphere, and another constructor, vec3, the center, and then a float r, and we'll do center sin, and then radius r, and we can create these variables down here. So it's going to be vec3 center and float radius. So this is just what we need to figure out where the circle is and how big it is. And now should be able to just take this function and copy it over here as well. So it's going to be virtual bool hit, and then we'll have constant at the end, just like that. And that's everything we need for here. And down here we can define the hit function for the sphere. Bool sphere hit. And maybe I can copy that again. Almost. Const. Now down here. Okay. So in here we're basically just going to calculate if the sphere has been hit, and from the rays, along with a few other things. But we're kind of just doing some of the same stuff that we did before, except for making it for a sphere class. We can have multiple spheres. So we're going to do vec3 OC equals r.origin, so the origin of the array minus the center, and then float a equals the dot of r direction. And then do we have some of this in here? Okay, let's copy this from here. Okay, and discriminant. Here, actually, we can copy this as well, except we're going to change this a little bit. Let's hopefully my indentating doesn't bother anyone. I do spaces on some and tabs on others. I'll organize it all later. But in here, the discriminant is that. We're going to be using rect t equals temp. And actually, but we need to set temp as well. So Yeah, actually, let's get rid of that. We're going to do, I guess some of it's going to be the exact same, but discriminant is greater than 0. Then in here we'll do we'll do float temp equals b minus the square root of b times b minus a times c divided by a. And now we can do if the temp is greater than T max and the temp is less than T min, then we'll do something in there, and down here we're just going to return false so I don't forget about it. So returning false there, and in here we'll do a new calculation for temp. Temp is going to be equal to negative b plus the square root of b times b minus a times c, and we'll divide that by a again. Then here we'll have the same thing right here. So now in this first one, we're going to do rect.t equals temp, rect.p equals r point, add parameter, and the parameter is going to be the center. Oh no, it's going to be t. And then rect.normal equals rect.p minus the center divided by radius. And then we're going to return true. And then down here is basically going to be the same thing. We just had two different checks for it. So it's going to be rect t equals temp, our point at parameter rect t. Okay, so that looks right. And now that we're going to go from here, we're going to keep track of something to list off all of these objects. So we're going to create a new file. We can call this one hittable list. So hittable list.h. And then in here we'll include a hittable. Save that. Okay. Now class hittable list is public hittable. And everything in here is going to be public as well. So hittable list just for the constructor. And then another constructor is going to take in some information. It's going to take in a hittable list basically. Then end to end is just going to be the size. So we can do list equals L and list size equals N. And we can even define these down here. List and int list size. And now let's go in here again. Let's copy this right here. And I think it's all going to be the exact same. Yeah, it looks right. And it's basically everything we need for that. Now down here, we can define a function for hitting it. So let's do bool hittable list hit. I'll copy that and paste it again. Okay. And here we're going to do hit record. Hit record equals temp record. And then Boolean hit anything equals false. So here we're basically just going to keep track of any of the hittables in the list have been hit. So we can do double closest so far equals T max. So we're going to keep track of what's the closest thing at least. So we're going to loop through everything basically. And here we're going to return if it's hit anything. So in here we can do int I equals 0, I is greater than list size, and I plus plus. So here we're just going to loop through the list basically. So then if list I equals hit, then we can pass in the same information, tmin, tmax, and go to the record. Well, actually, as we're looping through it, we can do the closest so far and the temp record. And we're checking that if it's done it. And if it has, we're going to do hit anything equals true. And we do closest so far equals temp rect.t. and we'll do rec equals temp rec. All right, and that should be everything for this. We're basically just looping through the list, checking every single one, and then just if it hits it, we're signing in, just letting it keeping track of what has been hit, basically. And now in our main function, we're going to want to change up some of this stuff. We don't need this array in here right now. I guess you could leave it, but we're going to be including our hittable list .h, and we're going to include our sphere, because we're going to be keeping track of a list and we're going to be creating some spheres. Okay, so now we basically don't need this. I'll just comment it out for right now, just in case. And in here, let's get rid of this as well, because we're creating two spheres. It's going to be a little different. And in here in our color function, we're going to want to take in the ray and a hittable scene. In the example book, it calls it a world, so we'll just call it a world as well. And in here, we're going to make a new hit record. So hit record equals rec. And it's going to be if the world hit, and it's just saying if it's hit 0, and then I'm going to change that to 0.001. It's kind of make it more accurate because we don't want it to get actually reach 0. And then we'll do max float, and we'll pass in the record. Okay, so if so, it'll do this, and else we'll do this. And the else should just be this right here. So let's delete that there. Indent that. So this is just the sky basically that we have it drawn. And in here we're going to want to figure out how to draw the world, or the circles. Or so yeah, I guess the world. So it's going to be this 0.5 times a vec3. And in these parentheses, we'll create our vec. It's going to be rec.normal.x plus 1, and rec.normal.y plus 1, and rec.normal.z plus 1. That should be everything we need. So let's go ahead and delete that as well. And in here, we can actually create our world and create our scene, basically. And we can do that, I guess, just right here. We do a hittable list. Well, let's just do 2. Like I said, we're going to use the first circle, and we're also going to add a circle below it for it to sit on. So we'll do 0 equals new sphere. And so we're going to pass in the location and the size. So location is a vec3, and the size for the first one is 0.5. So I guess it's the same thing up here. So we could use the same thing, but we're going to be doing more stuff, so for right now I'm just getting rid of that basically. Now let's copy that, and then down here is going to be 1. This circle is going to be a lot bigger. Make it size 100, and we're going to move it down 100.5, so it's going to be directly below it. And that's basically all we need for that. Actually, we need hittable world equals new hittable list, and the size of it is 2. And then down here, we want to make sure that everything is being drawn correctly. Ray origin, vec3 color. So let's change this right here. We do vec3 p equals r point, add parameter 2.0, and vec3 color equals color r world. And that should do it. Let's build it. I'm sure there's some errors, so let's check for that. In our hittable class, we need to make sure to include the ray class, because remember we got rid of that in here because it should be in here. So let's do that. And in our hittable list, I forgot to put a semicolon right here at the end of the class. Okay, so one fix that I guess I just did off camera, but I need to mention with everything, is that each one of these header classes, I need to add a define thing. So you just need to want to add this, if and define, and then hittable H for hittable, define, hittable, and at the end, end date, end if. That's because some things are being redefined multiple times in the way that we were sharing the headers. So that was a fix. So I just had to quickly go and do all that. And here you can do the sphere one. And there's end if, hittable list H, and end if. Same thing for the ray one that we did yesterday and the vec one. I just called it vec H. But it doesn't really matter too much about the names. Just make sure that they're all on their own. They're defined separately, so there's no double definition of classes or structures or functions or anything like that. And I think there was another error or two. So in the sphere class, this needs 2 colons. Maybe you guys got that already. And in the sphere class also, this was double defined. I think I copied and pasted it twice. And in our main class on line 29, this is not defined, so define that as T. Here in the sphere class, we had 4 here. 4 was originally in this hit sphere function, but in this hit sphere function, we don't need that, so we can remove that. Also, we want to remove this times 2, and I added the semicolon here on accident. I had it up there, but I did it here too for some reason. So now we can run it, or build it first. Now let's run it, and it takes a second. And here we go. As we can see, there's the sphere as before, and there's the sphere below it. And it's the top of the sphere, so it's green, just like it's green up here. Let's save this into an image. I'll do 5 b.ppm. Now let's open this image up. Now if we were to zoom in here, you can see that it's kind of rigid, which is kind of expected. It's expected to have ridges everywhere. So what we're going to do is do some anti-aliasing, because things like this aren't rigid in real life, which, I mean, we're not going to be perfect. But even if you were to take a photo with your camera is doing pixels just like this too. And it's not picking up rigid stuff either. So we're going to at least do some anti-aliasing. We're going to be using some randomness on every single pixel. And to do that, we're going to be setting up a camera class. So we're going to be taking some of this stuff that we talked about in the last time for the eye or the camera, and we're setting up a class using that, and then doing some anti-aliasing with some of that stuff. So right here, let's create our new file. Let's save it. It's camera.h. And we'll do this that we mentioned before, if and define camera h, and then we'll define it camera h, and then end if down here. So we can create our actual class down here. The camera is going to include the array, so array.h, and we'll have a class camera. Let's close that off, and everything in here is going to be public. Our constructor, we can even define it right here. We can just copy some of this stuff. We'll just copy this. Here. So we don't need the vec3, since we're going to define it right after. And yeah, so let's define these. Vec3, lower left corner, horizontal, vertical, and origin. Vertical, origin. Yeah, okay. And we'll set a function for getting array. So array, get array, float u, and float v. So that's going to be similar to what we did also. Return array, and it's going to be the origin. Actually, copy this as well. So we're going to be getting rid of this, and in here, we're doing this right here. So we can comment this out for right now. so you can remember where it was. Okay, so now it's going to return array with all these parameters. And now in our main function, we can go ahead and, so we got rid of that first part. And now down here, float u and v, we're going to want to do, like I mentioned, we're going to use some randomness. So it's drand 48 actually. That'll be used right there as well. And then right here, we're going to want to do array r equals cam.getRay. So we're going to want to find the camera as well. The UV. And then I guess we need to find our camera right up here. Camera cam. Make sure to include it. Include camera.h. So now we've got that set up. Let's we're using a variable. We're calling it ns. So ns equals 100. And down here, we're going to want to do right here, we want to define our color because we're going to be manipulating it a little bit. So the color is just going to be set to 0 at first. And here we'll create a loop using an ns. So it's going to be int I, int s equals 0. S is great, s is less than ns. S plus plus. Close that off. Then in here, so I guess I delete this now. I'll delete this as well. So in here we can move all this stuff. Can I tab this? Yep, okay, perfect. So that's going to be move the camera, and then this one is not being created, it's going to be added onto it. And then right here, when I do color, divided by the float ns. Okay, and that should work. Let's build that to test it out. And no matching function in the call. Okay. And here, okay, so yeah, so I guess I couldn't directly copy it. It's going to be vec3. Let's just copy that. Okay. Now let's run that. Oh wow. Okay, so that is not correct. I'm going to save this though. I guess the error was caused because this needs to be minus origin as well. Okay, and there's one thing we need to fix in this vector class that we did yesterday. Here in our public part of the class, we have this inline vec3. It's just going to be defined as this. Return this, this 1/2. So just like that. Down here we had this originally, but that was incorrect. So you can go ahead and remove this that we had. Multiplication one's right, this division one's wrong. And I mean, all this can just be added to this line. But that was affecting this right here. But we can see, I'm going to go ahead and turn off the STL2 so it runs a little faster. And because we need to check the anti-aliasing. Actually, I'll just skip it in the video. Now we can see here, after running it, it creates this image, and if we zoom in, there's more anti-aliasing. It's less jagged. It takes the foreground and the background, and it kind of mixes them together. So you can see it looks a lot smoother now. Of course, if you're zoomed in, it'll still be a little jagged, but it looks a lot better. So now we're going to try to do some light, some diffusing of the light. So let's say, now we have the shadow as well, but let's say we have the sphere underneath it, and we want to have some shadow down here as well. So our array is coming in from over here, it's bouncing everywhere, and we want it to be able to, I guess that's the surface, this is a side view. We want the lights to be able to bounce down here, here, and here, and be able to bounce in different directions. So that's what we're going to work on right now, to figure out the lighting and diffusing the lighting basically. And to do that, we're going to be using something similar that we were doing, where it's just going to be taking the center and finding some random points and finding the differences and bouncing them around. So back in the code, we can back up that vector class again, and we're creating a new function down here. Go ahead and delete that. New function right here, and it's going to be called vec3 random in unit sphere. And it's going to be vec3p, and it's going to be do, and then we'll return p. So in this do, we're going to have it do something for a while, and it's going to be p dot squared length is greater or equal than 1. The squared length or length squared? Length squared, okay. Length squared. So now let's do, we're going to want to do p equals 2.0 times vec3 of that dran. It's a dran 48. And so you can just copy that. Close it off, and minus vec3 of 1, 1, 1. Alright, just like that. And now back in our main class, we're going to want to change some of this color function. And changing that, we're just going to add the randomness. So that's going to be right in here. We'll do vec3, call it target. That'll equal to rect.p plus rect.normal plus the random in unit sphere. Actually, I'm going to move this into the sphere class. Makes a little more sense. In unit sphere, just like that. And then here, what are we going to change? It's going to be, I guess we can, let's delete this. It's going to be color, close it off. It'll be ray, and then world. And in the ray, it'll be rec.p, and then target minus rec.p. Alrighty, so that's because the rays are going to be bouncing around. So it's going to bounce down here, it's going to bounce up there, and bounce over there. It's going to keep going as far as it can until it reaches nothing. So that's why it's just going to be calling itself over and over until it finally, the ray just comes to a dead end. So we can build this real quick. And say this is 8a.ppm. No, 7, my bad. 7a.ppm. And here we have it. As you can see, it loaded. There's the sphere, and here's the lighting. So the rays are bouncing over here. They're bouncing around until they're finally released somewhere that they're not being hit. And you're able to get the colors for everything. We're going to, it's a little dark. We're going to make it look a little bit lighter. We can do that down here. So after that, it's going to be that. And then we can do color equals vec3. And we'll do the square root. So it's going to be color dot r, and then copy this, RGB. And then let's try running that again. And perfect. This is exactly what we're looking for. It's a little bit lighter. There's less shadows, or the shadows aren't as dark. It looks a lot better. So now that we've got this all set up, we've got our world, the scene of multiple spheres using lighting. We're going to add some more spheres, and we're going to add some material types. So we can have this matte finish, and we can also have a metal type object, and then they're going to be able to have reflections as well. So we're going to create a new file and a new class, and it's going to, I want to make a new tab. It's going to be called material, so material.h, and then we'll if not defined, material h, define material h, and if down here. Now let's have a class material, and then close it off, public, and virtual bool scatter. So the scatter is basically just going to be telling the different material types how they should react to the rays, or I guess telling the rays how they should react to the material types. Constant ray, ray in, and then constant, save that, this looks better, constant hit record, rec, and then vec3, attenuation, and ray scattered. So that's basically everything we're going to need for this class. We're going to have different material types. I guess we'll be adding them in here too. And in our hittable class, right over here, we're going to want to define the array. So we can do class material. We're not including the material class in here, but we'll just have it in here so it'll work. It'll be material, and it'll be a pointer. You can just call it mat pointer. And then that should be everything that we need in here as well. Back in our material class, we can create new classes for the types of materials. We'll call this Lambertian, and this will be a material. And this will have everything public in here, and it'll be Lambertian, and that'll be the constructor. And we're going to want to do const vec3, and call it a, and we'll have something called albedo, and have that as a. And we'll define this down here, just like that. Okay. And now we're going to have this function. So let's copy that right here, and we can define it in here as well. So it's going to be vec3 target equals rec.p plus rec.normal plus random in unit sphere. So if you can tell, it's basically the same thing that we had before, because this is going to be a mat-like type material. So it's going to be array rec.p target minus rec.p, and attenuation equals albedo. Now we can return true. Okay. And now we're going to want to have some sort of reflecting material, and that one is going to be a metal class. We can go ahead and copy that down here, and we'll call it metal, and that'll be metal as well. We can leave that here. Now we're going to change some of it, but we're going to be making a function also for reflections. So imagine that we have a ray coming down. It's going to need to reflect and then bring back the color, basically. And I guess we'll explain it as we code it, but we're going to be creating a function for the reflections, and we can put that in this vector class. So this one I think should go in here. So vec3 reflect constant vec3, call that one v, then constant vec3, and we'll call this one n. And here it's just going to return v minus 2, put some space and make it a little more readable, minus 2 vn times n. Okay, and that's basically what we need to do to get the reflections. And now that we have that, we can set up our metal class. So it's going to be vec3 reflected. We'll call the reflect, what's here? Actually, get rid of all this. Call the reflect function. And in here it's going to be unit vector. And there it's going to be rn direction. And right after that, we're going to have our rec normal. And then the scattered will remain, the scattered right here will be reflected. And this will remain the same. And then return is going to be dot greater than 0. It's going to be dot scattered dot direction. And the rec normal. Okay. So that should work. for that. Now we just need to change some of our color and some of our main function. I'm going to go ahead and delete this as well, and we should include our material class right here, and in the color class we're going to change up some of it. So we're going to have a depth, so that's going to be in depth, and in here we're going to change up here. Everything in here should remain the same, because as always that's just the sky. So we'll have array scattered, just like we had it be called in the other one, and attenuation. So if the depth is a certain size, we'll do something. If not, we'll do something else. So in here, let's do this one quickly. Let's return vec3 of 0, 0, 0. Okay. And now in here, if the depth is greater than 50 and the rec material pointer scatter of r rec attenuation scattered, then we're returning attenuation times color scattered world depth plus 1. Okay, so even though we got rid of this part right here is going to continue to iterate through it and do it over and over. And now in here we're going to change up some of this as well. So our spheres are going to be created differently. We're going to be creating 4 spheres also. So let's do this as 4, and let's copy this so we can double it. That's going to be 2, that'll be 3, and in here we're going to want to say what type of material it is. So these ones right here are going to be new. So the two ones we already had, they're going to remain the matte type finish, Lombardian, and it's going to be vec3. And here it's going to be 0 0.8, 0 0.3, and 0 0.3. And I'll copy that for this same one right here that we had before. We can change it up a little bit. That can be 0.8, that can be 0.8. Okay, and then for this circle, we're going to want to move around the position as well. This one can be at 1, 1. This one can be at -1. That'll be at 0. And then this can be -1. Okay, perfect. And then the size, this one could be 1.5. Now this one's going to be new metal. It's going to be vec3. And then in here, we can do, actually I think that I want this one to be 0. Then this one is going to be 0.8. This one will be 0.6 and 0.2. So we can copy that right here, make that one a 0.8 and that one 0.8. And then, do we need to change anything for it to be in the scene differently? I don't think so. Let's try running it. Okay, so yeah, so the color needs to be changed. The depth, it's going to start off at 0. Is there, call the function anywhere else? No, I don't think so. In material, I have that as vec right there, and that one is vec, so that needs to be fixed. And we also need to add a colon right here and right there. And in our sphere class, we need to add material as well. So material. Okay, and then we do same thing that we did in, I don't know what class that was we were looking at. The hittable. Yeah, okay. So the same thing we did right here, we'll do in the sphere class. And then down here, we'll define them. So we can pass in the material as well. So it's going to be material M, and right here will be matte pointer M, and then down here we can set them. So rect.matPointer will equal to material. And then rect.matPointer will equal to material. Oh, that right there is going to be matPointer as well. MatPointer. And here in the material, this alteration needs to be a reference. And also, is there anything else that needs to be fixed? Then here we define struct hit record just to make sure it's not an error. Correct. Okay. And then this one right here needs that as well. Let's spit that out into 8 ppm. And here we have it. Let's make it a little bigger. We have this matte finish, that one down there as well, and these are the materials that are metal, that have the reflection. See, they have the reflection for the objects beside them, and the reflection from the ground. That's pretty cool. You can see the dithering still works for the lighting, and the anti-aliasing as well. The reflection's pretty smooth, so what we can do is we can add a little fuzziness, so you can make it so some metal materials reflect more than others. So let's go ahead and do that. We can do that in our material class for the metal. Let's just add, I guess we can keep track of the fuzziness right here. Let's call it float F. We can do fuzz F down here. Let's define that as fuzz right there. And now the fuzziness is going to be a randomness, sort of. It's going to make it so any of the points that move out, they kind of are moved out just a little bit off, basically, using the fuzziness and some randomness. So in here we want to define fuzziness just in case it's not defined or something like that. So F is greater than 1. Then just to make sure, I guess the fuzziness is within 1. Else fuzz equals 1. Okay, perfect. So I guess we don't need that actually. Now that we have that right in the scattered line, we have the ray. So this one's going to be reflected plus the fuzz times random in unit sphere. And that should be everything to do it. What's in here, I guess we have to define the fuzziness. That's for the metal ones, so we can do 1.2 for this one, and this one could be 1.7. So you can see they're a little bit different than each other. Let's call this 182, and I'll skip it to once it's loaded. And here we have it. As you can see, this material right here is more reflective than this one right here. And that's just because of the fuzziness. So this is everything for day 2. This has been day 2 of ray tracing in one weekend. Hopefully you guys enjoyed today's video and followed along well. There's a little more errors than I hoped for. I'm going to try to cut out as many of them as possible. Everything, as always, is linked in the description. You get the code on GitHub. But yeah, leave a like if you guys enjoyed it, and see you guys again next time. Bye.